So, get the smart board flipped over. And the little words and or are going to be pretty big, and you're right saying they'll be pretty big in this lesson today because they mean some pretty important stuff when we're doing set operations. So we're going to start off here with what we're going to call an intersection. And we're going to have a new symbol today for intersection for some of us. It's like a big upside down U, and that's going to insinuate the word and to us. Okay, so we're looking like that. All right, now, if you got that, Chase, if we saw something that was an intersection on a Venn diagram, the part that intersected would be the part where it overlapped, right? It'd be the part that was in both. Okay, so if I gave us a set of numbers and said set A contains the numbers 3, 4, 5, and 6, and set B contains the numbers 5, 6, and 7. And I ask you to tell me the intersection of set A and B. That's how that reads. That's how we would read this right here. The intersection of set A and B. All you're going to say are what numbers are in both sets, because and means they have to be in both. So what numbers do we have that are overlapping in both sets?
5, 6.
Out of kid. So that would be our answer. Okay? Pretty simple on stuff like that. Ands, when it's an intersection, when you're dealing with and we're going to be looking at these on a number line, that means it's got to be in both of them. You have to be, we could say we are in math and algebra 3, because that's the same thing. Okay? But we can't be in room 121 and room 116 at the same time. That's not possible. You're in one or the other. So, and you could be in both of them. All right. Making this connection with the problems that we were doing yesterday, I've got x plus 3 is less than 1. And I'm going to underline it this time because we're emphasizing that, x minus 4 is greater than negative 12. Okay, everybody here? Easy one step to solve both of those. So let's go ahead and solve them. Oh, what was it less than? I didn't write that one. Thank you. Easy one step to solve both of those. Go ahead and get them solved. We would subtract our 3 here. X is less than negative 2. And we would add our 4 here. X is greater than negative 8. Now what we're going to have to do with these, we're going to have to solve them, check. We're going to put them on a number line, and we're going to have to write them in interval notation. Okay? When I start with you on this, I'm going to initially give us 2 number lines, and we're going to put them separate. This is not my answer. This is just me trying to get you to visualize how this works. If I take my first one, x is less than negative 2, it would look like that, right? Mm-hmm. Okay. My second one, x is greater than negative 8. Negative 8 is farther to the left, so it would look like that, right? Mm-hmm. So what we're supposed to graph is the intersection of those two sets. So I'm looking for what numbers would be shaded on both of those graphs. So if I were to morph these down together, I'm looking for that section where they're both shaded. Does that make sense? Mm-hmm. Okay, so on my answer graph, I'm going to put those two together. And I'm shaded to the right of negative 8 with the parentheses, and to the left of negative 2 with the parentheses. So only the part where the shadings overlap are part of my answer. Okay, remember that? So interval notation will be negative 8 to negative 2. Okay, only the part where they overlap. So it's like if I took that section in there, right? That's the only part that both lines were shaded on. Does that make sense? Here's a connection, and you'll see this in a few minutes when we get to ones that are or. If I'm and, like I said, I can't be in this room and a room across the hall at the same time. So my answer space is smaller. But if I said or, I could be in this room or that room across the hall, right? So my answer space is bigger. Most of the time, and graphs are shaded in the middle. Most of the time. There are some weird ones that we're fixing to look at because we got to cover all the weirdies. But the normal ones, most of the time, are shaded in the middle on and. Or will be different. And I'll talk about that in a second. Okay? Alright, that's the normal type. Everybody good on that? Easy schmeezy solving them. Just got to make sure we get the number lines right. Alright, we're going to look at a couple of the weird ones now. Here I've got 2x is less than or equal to 4x plus 8 and 3x is greater than or equal to negative 9. Alright, so we got an extra step on the one on the left. What would we do? What could you do first to start solving the one on the left? Okay, I'm with Aaron on that. We're going to subtract 4x from both sides. Gives us negative 2x is less than or equal to 8. Then what would Aaron have to do?
Have to divide by 2.
Divide by negative 2, which means Aaron better not forget to flip that sign, right? So we divide by negative. Y'all follow that? Remember that from yesterday?
Yep.
Alright, and we just got one step over here. Just divide by that 3. Do I need to flip my sign?
Nope.
No, good Mason, because I divided by a positive 3. I don't care about the 9. It doesn't matter. Poor thing. It's kind of like me. Doesn't matter. Alright, let's look at how this is going to look on our number line. I want to make 2 of them again. My first one, here's negative 4. It's got an equal bar, so it gets a bracket greater than that. Would go to the right. Okay, now when I put my second number line, negative, whoops, let's pretend that's straight. Negative 3 is to the right of negative 4, isn't it?
Mm-hmm.
So it would go like that. Now remember, this is an and, so I'm looking for numbers that can be in both of those shaded sections. So if I am back here, am I in both of them? If I jumped off of this number line where I'm circling right there and landed on the other number line, would I be in the shaded part?
No.
No. So the part that's in both of them would only be from the negative 3, right? Everything from there on is in both of them. So we would say for our number line answer, negative 4 didn't even matter anymore. So it would be from negative 3 to infinity. Okay? Okay, now remember in that connection, the common sense that we've been making, when we're an and, we're limited. It's impossible to be in 2 places at once. So our answers are sometimes smaller. So if I had had this whole thing as my answer, that would have been bigger, right? I went with the smaller one because it's an and. That's going to be important because we're going to get an or in a minute and rules are going to change. Mason will have the shaggy dog there for a minute. I looked up and all I could see was hair on his face. Alright, one more weird and, intersection and, one more weird one of those. I've got x plus 2 is greater than 3 and 2x plus 1 is less than negative 3. Okay, this is another abnormal one. Should have the one on the left solved already. Everybody get that?
Mm-hmm.
Okay, what about the one over here? Everybody get that? Okay. Now some of you notice something's fishy already. But for the rest of us, we'll go ahead and look on our number line and see. Here I've got 1 greater than, it would be like that, right?
Mm-hmm.
On my other number line, negative 2 would be to the left of 1, so it'd be over here. And less than would be like that. I'm looking for the intersection of those 2 sets. So I'm looking for, if I drop that top number line down on the bottom one, where would it have shading overlapping?
Never.
Never. Very good. It's impossible for me to be over here and over here at the same time, right? It's impossible. So how do we write our answer for that? Good, good, good. No solution. Good job. Okay. I think we mastered intersections. Yes, no, maybe?
Yep.
Okay, the other topic is unions. The symbol for union is just the opposite of intersection. It's the big U. And the word that will go with unions is or. Okay? Meaning we can meaning we can be in either or place. So if we went back to that example that we started off with when I said set A had the numbers 3, 4, 5, and 6. And set B had the numbers 5, 6, and 7. And I ask you for the union of sets A and B. Okay, now before you start telling me the answer, make sure we get it. If we think of our Venn diagram, when it was and, it was only the overlapping part, right? But when it's or, I can be in this circle or that circle. So it would include anything would be our union. Okay, so if I want the union of sets A and B, what numbers am I going to list?
3 to 7.
Very good, all of them, right? Everybody okay on that? Is there if it's in one, you can be there, okay? You said, well, 3's not in that one. Yeah, but it's in this one. So 3 is in either A or B. It's in one or the other. Okay? All right. Now don't forget about the intersections that we did. Remember I told you, and y'all are mocking me, and I'm digging it. Most of the graphs on an intersection, the middle is shaded. The inside is shaded. Okay? Fixing to shift gears with unions. I was giving you a hint a minute ago, but we're going to see it right now. Brown cow. I've got x minus 1 is greater than 2, or 3x plus 5 is less than 2x plus 6. Okay? Alright, left one's a no-brainer to solve. Add your 1. Everybody got it? Got an x that's greater than 3 on the left? Okay, a couple more steps on the right. What do you want to do first to solve the one on the right?
Subtract 5.
Okay, we just subtract 5. Whoever said the 2x up there would need to subtract that in just a minute. That gets me 3x is less than 2x plus 1. Now I'm ready for that 2x that the guy said at the front. Subtract it. So x is less than 1. So we got x is greater than 3, or x is less than 1. Okay? Let's look at how this is going to appear on our number lines. Make sure you put these in numerical order. I always tell you that students mess it up. I messed it up this morning. So, greater than 3 would look like that. 1 would go to the left of 3. I forgot that this morning. Less than 1 would go like that. Alright, now if we were looking for an intersection here like we were on the previous problems, this one would be no solution. There's not any overlapping on that. But it didn't say intersection, it said or. So can I be one or the other of these?
Yep.
Yes. So my answer graph is going to just bring those two together. I'm going to have 1. Remember the difference between parentheses and brackets? We haven't been emphasizing that, but y'all did good on it all up until now. And then 3. So that would be what my answer graph would look like. Now, I really like writing the interval notation on these unions because there's more than one piece and it looks fancy. You can trick people into thinking you're smart when you write fancy symbols like this. This forever goes to the left, so that's negative infinity. And then we go to 1 with the parentheses. What did we say the symbol for this or thing was?
That's U.
U, union with 3 to forever to the right, infinity. I like writing those, make people think we look smart.
We are smart.
That's right, Caleb.
Yeah.
Caleb is a smart filler or a fort smeller.
Both. Wink, wink.
All right, so
No, that.
the ands, the intersections, the graphs meet in the middle on the normal ones. Okay, the ors, the unions, the graphs go out to the sides on the normal one. Okay, keep that in your brain, store that, because now we're going to do, just like on the intersections, there were a couple of weird ones where we had the no solution, all that. There's some weird ones with this, so we're going to look at the couple of weird ones. But this is the normal stuff. These are what you'll see the majority of the time. Ands in the middle, ors out on the edges. All right. If we had 3x minus 2 is less than or equal to 13, or x plus 5 is less than or equal to 7. Those are both less than or equal to. I don't know if I read the first one right. Okay, let's get this thing solved. You got them there? Got them? We're adding 2. So we got 3x is less than or equal to 15. Divided by 3. Did you get that? Everybody okay there? Okay, just got one step on the one on the right. It's an easy one. Subtract a mundo on that 5. Okay. Alright, how's this going to look on our number line? Got a bracket with a 5 going to the left. Okay, then with my 2 is to the right of 5, and that would be a bracket and go to the left. Alright, we ended up with something like this on the intersections, on the ands, and we had to be in both of them, so we took the smaller stuff. But now I can be in either one of them, either or. So if I'm over here real close to this 5, I'm not in the bottom shade, but does that matter on an or? Good, no it does not. You can be in either one of them. So when it's an or, the connection that we're going to make, Chase, is to take the bigger information. Or let you, like I said with the classrooms, or I can be in either or classroom. I got more options. So I'm going to take the bigger, so it's going to be the 5. So we'll say that we go from negative infinity, that was a bad infinity symbol, to 5. Alright, so next one, you're going to try on your own. We're getting there, y'all doing good.
Oh, man.
Okay. Oh, I thought you said timeout. What'd you say? What did you say?
I feel,
He said, oh man.
Oh man, okay, look.
Oh, man.
I thought he said timeout. I was like,
I mean, sure, time out. 10-minute break.
it's a long timeout.
That time.
That's like longer than Super Bowl timeout.
Tailgate time.
That's what you just wrote.
Yeah, I'm switching one side. This first period started yelling at me too. Alright, so you see that on the previous problem, I just switched a sign. Everything is the same except one sign switched. Okay, so you ought to be able to get them solved pretty quick. The numbers are going to be the same. You just got a sign flip. So, you're doing this one on your own. Go, try this one on your own. See if you can solve it, get the number line, and get the interval notation. And I remember I warned you, this is one that's weird. Okay, so try it, talk to your neighbors, see what they got. Try something.
sign moved, I told you that.
Yeah. I did.
I think I might know what it is. I'm not sure.
Alright, I got them solved because we just solved it on the previous problem, so that wasn't that difficult. Now when I start putting them on our number line, one of the signs was changed, so one of my number lines is going to be a little bit different. If I'm here at 5, less than or equal to, it's going there. If I'm a little to the left of that at 2, greater than or equal to is going here. Now, if this had been an intersection problem, an and problem, I would only put on my answer that part where they overlap. I would only have that shaded, right? But it's an or. So I can be way over here, or I can be way over here. So what's going to be shaded on my number line? Most of y'all had it.
Everything.
Everything. Very good. So on my number line, I'm going to shade everything. So just shade everything real quick. That's real hard. So that goes forever to the left, forever to the right. There's your interval notation. Okay? Alright, I got 2 more I'm going to give you in your notes to try, and then we'll have an exit question in a second after that. So everybody got what you need on that? These, what I'm going to do with the 2, y'all listen fellas, what I'm going to do with the 2 that I'm fixing to give you, they're going to be back to the normal kind to remind you what the majority of these look like. The ands coming in the middle and the or's going to the outer. So everybody got what you need there? Alright, this one says, not that one. Yes. X minus 3 is less than or equal to 6. And x plus 2 is greater than or equal to 7. There's number 1. Solve graph interval notation. Number 2 says x plus 1 is greater than 3. Or x plus 4 is less than 2. Okay, solve both of those, put them both on number lines, and put them both in interval notation. Got them?
Almost.
Almost.
Okay, you're doing good.
Are these weird ones?
Nope.
Nope.
Yeah.
Nope.
Okay, never mind. Figured out what I was doing.
Good, good, good.
No, you didn't. You're running low on ink.
Maintain. Can you go get your sneak?
What? I don't know. I'm running with him.
With me?
Yeah.
Since when?
Okay, I've got mine solved. Did I get the right solutions at least? Y'all focus. Y'all done well. Everybody good on the solutions? Y'all put them on a number line now. I'm going to try to just go straight to one number line now. Since we've been practicing all period, maybe I don't have to do both before I go to the one. So I've got 9 and 5. I need to make sure I put them in the correct numerical order. 5 is smaller than 9. Okay, so if I'm less than or equal to 9, it's got a bracket and it's coming to the left. If I'm greater than or equal to 5, it has a bracket and it's going to the right. Is that good on my number line?
Yep.
Okay, good. My interval notation would be 5, 9, and they both got brackets because they both got the equal bar underneath it. How'd you do?
Splendid.
Good,
Splendid.
good. I like it. I like it a lot. All right, the bottom one. Got -2 is smaller, so I need to put it on the left. 2 goes on the right. These both just have a parentheses. Greater than 2 be a parentheses and greater's to the right. Less than -2 be a parentheses and less is to the left. So how's my number line?
Good.
Good, good, good. All right, interval notation. When we have these unions, we have to use the union symbol. So we are negative infinity
-2.
to -2.
Union.
Union
2.
to
-2 infinity.
infinity. Very good. I should have written it all in one line, but I
To
didn't
infinity.
think very well. All right, and beyond. Very good. All right, got an easy exit question. I'm hitting ask right now. It just showed up in mine.
I'm in.
Open yours, refresh if you need to. Got an exit question? Got an exit question?
Man.
I got an exit question. I got an exit question.